this is section 9.2, and we are going to study the ellipse. The ellipse is another form of conic section, and it looks like an oval, so we'll have these two different styles. One of them is going to open and be stretched with the x-axis, and we could have an ellipse that is stretched with the y-axis. Okay, so there'll be all sorts of different parts to this ellipse, different points that are considered to be important pieces. We'll find the center, and let's look at the equations or the definition of an ellipse. Here's the definition. A set of all points x, y in a plane where the sum of the distances from the two distinct points called the foci is constant. All right. Here's an ellipse. Here are all the important parts that we have with an ellipse. We've got a center, we also have 2 points that are called the foci, or the foci. And they are just inside here, the ellipse. Just inside. We also have points here that are important, the ones that are further away from the center, so the one that's being stretched. These are called vertices. And the last 2 points are the ones that are closer to the center. These are covertices. I'm just going to call them C and V. Covertices. Well, here's what the definition says. The definition says any point on the ellipse, so let's say this point, where the sum of the distances from the two distinct points called the foci. So there's a distance between each of the foci. And we're going to call it D1 and D2. Well, D1 plus D2 equals some constant. Because if I change this point around to here, this distance, again, the sum of the two distances, still equals the same constant. These are the same. So the point that would rotate all the way around this ellipse, they're always the same distance away from both foci once you add those distances together. And so that's how these points are created. Here's the standard form for a ellipse. You've got your, on top, x minus h squared, y minus k squared. On bottom, you've got these a squared and b squareds. Now, in the ellipse here, the a squared is always the largest. A squared is always larger than b squared. So this is important because that's going to control which direction it's being stretched. So if a is the larger value and it's underneath the x's, then you are stretching it with the x-axis. And if your a squared is below your y's, then you're going to stretch it with the y-axis. So this one here is more oblong with the x-axis. And the one down here is more stretched with the y-axis. And that's because of where the larger number is, whether it's below the x's or below the y's. Now your HK is still your vertex. And then your equation is equal to 1. We also have what's called major and minor axis. A major axis is the longest axis. It is 2a units long and connect the vertices. So here's what we've got. If this is my ellipse, then this is the major axis. It's from the vertex here all the way to the other vertex. And the length of it is 2a. From here all the way across is the length of 2a. The minor axis. The minor axis would then be the axis that goes the other direction. So my minor axis is going to be from a covertex to the covertex, and the length between those two is 2b. So major is longer axis, minor is the smaller axis. The foci, 2 points that are c units from the center of the ellipse. The foci lie on the major axis. To find that c value, you do c squared equals a squared minus b squared. All right, now let's again look at an ellipse, and we'll start putting some of these pieces together. If this is my ellipse, and the first vertex here is 4 units from the origin, the other vertex would also then be equidistant, so 4 units from the origin. And let's say then my covertices are 2 units above, 2 units below. So let's talk about what we know. We know this, that the distance from here all the way to the end is 2a. That means the a value would be half of it. So from -4 to +4 is 8, so half of it would be 4 units. And we know going vertical here, the distance between the two covertices, these 2 points, is 4 units. So that is also 2b is 4, so then b would equal 2. All right, well that's no different than saying this. The distance between the center and the covertex is 2, and the distance between the center and vertex here is 4. So we know a is 4, b is 2. Or a squared would be 4 squared minus b squared is 2 squared. So 16 minus 4 is 12. So c would equal the square root of 12, which is 2 square roots of 3. So the covertex, or the foci is this many measures away from here. So you're going to see that the covertex would lie in here somewhere, or the focus would lie in here. And then over on this side, it'd be the same distance away. But that's where they're located, and they're located along the major axis, and the major axis runs horizontal here. So that's all the important parts to to our ellipse. All right, here's the actual equation for it then. In general form, ax squared plus by squared plus cx plus dy plus e is 0. We have both x's and y's are being squared. You have also x's and y's, and sometimes you have to complete the square in order to get it into our standard form. And the last thing here is what eccentricity is. Eccentricity will tell us how close to a circle that the ellipse is. And this is how you find it. The c value divided by your a value. So e is equal to c over a. As the ellipse becomes more circular, e gets smaller. The ratio here will get smaller. That's just one other extra calculation that we will be doing. All right, here's our first example. So what I'm going to do is, a lot of times what we'll do is we'll kind of sketch out what we know and be able to identify some things. Find the standard equation of an ellipse having foci at 0, 1, so if we assume that the center here is going to be the origin, but you've got your foci at 0, 1, and that means there's going to be another one at 0, -1. And 4, 1, let's go back here. We've got another foci at 4, 1. What this tells me is that my major axis runs horizontal. My major axis goes horizontal. You could also determine where the middle is going to be because the foci are going to be equidistant. So let's go ahead and identify the center of this. The center is going to be at 2, 1. So here's my center. My center, 2, 1. Now I can start writing my equation. This is going to be x minus 2 squared plus y minus 1 squared, because remember you put your center in the HK. What we need to figure out is what goes on bottom. And the last thing that we know is the major axis has length 6. Let's put the major axis in. If the major axis is length of 6, that means it has to be 3 in one direction. So this would be a vertex. And go 3 in the other direction. This would be a vertex. Okay. So these points are our vertices. That means my A value, since it's the major axis, the A value is the distance between the center and the vertex, which is 3 units. So A equals 3. And since it goes with the x-axis, it's then 3 squared, because that's where your A squared would be below your x's. The only other piece of information that we do not have is the B value, but we know the C value. Our C value, again, was how many units away. This is our C value. So that's just 2 units. So we know that C is 2. And here's how we find our focus. Remember, there's an equation. It's C squared equals A squared minus B squared. So we know that C squared is 2 squared, and A was 3, so 3 squared equals negative B squared. So we've got 4 equals 9 minus B squared. That concludes that negative 5 is equal to negative B squared, or B squared is equal to positive 5. So B has to equal the square root of 5. So let's label that. B is the square root of 5. And if you put it into the formula, it would be the square root of 5 squared. So here's our standard equation. X minus 2 squared plus y minus 1 squared, that comes from the vertex. Below your x's is the minor axis. The A value comes from the major axis, which is 3. 3 squared is 9. And the minor axis below the y's, which is 5, equals 1. And there you have it. There's our standard equation. We also know that the square root of 5 would be approximately a little bit more than 2. So our ellipse looks like this. And it'd be down a little bit more than 2, but not much. There you go. So this distance right here was the C value. This distance is the A value, and we have one more. And this distance is the B value. And all that gets put together to make my equation. The last thing that we need to do is do the eccentricity. Eccentricity is E equals, and it's always the C value over the A value, C over A. Well, in this case, our C is 2, and our A is 3, which is 2/3. And there you have it. All right, let's try another one. Example 2. Sketch the ellipse given by the equation. Well, it's not in standard form yet, and we need to get it to standard form. Standard form would be when you have all of your left side equal to 1. So how do we get this whole thing equal to 1? We do that by dividing by 36 on everything. So if I divide by 36, I've got x squared over 9 plus y squared over 36 equals 1. So here's my standard form. The center is the 0. 0, it's the origin. Let's go ahead and start marking some of this. Center is the origin. Okay, I know because my the value below my y squared, since this is larger, that's going to be my major axis is going to be with the y. So we know that this is our a squared. So a squared is equal to 36. So then a has to be 6. So we go 6 units up. There's a vertex. 6 units down. There's a vertex. And that means the length of the major axis is 6 and 6, which is 12. Major axis endpoints would be 0, 6, and 0, negative 6. Okay, the minor axis. Well, the minor axis is going to come from our b squared. So this is b squared equals 9. So b is equal to 3. So 3 units out. 3 units to the right, 3 units to the left. So that's negative 3, 0, and 3, 0. And there's our ellipse. Try drawing that one again. That's a little bit better. All right, let's find our c value. So c squared is equal to, it's a squared minus b squared. C squared would equal, our a is 36 and our b squared is 9. That's 27. So c would equal the square root of 27, which is 3 square roots of 3. So the foci would be 3 square roots of 3 units away from the origin. Well, 3 square roots of 3 is a little bit more than 5. So here and here. But the points, how far away? The points would be 0, 3 square roots of 3, and 0, negative 3 square roots of 3. Those are the actual locations of them because, again, it's how far away they are from the center. All of these points are how far away it is from the center. All right, and finally, the eccentricity. E would equal c over a. So E is equal to 3 square roots of 3 over the a value. And the a value is how long the axis is, which is, or how long the a value is. So here's my a, which is 6. So 3 square roots of 3 over 6, which is the square root of 3 over 2. So there's your eccentricity. And that's all the important parts for this problem. All right, example 3. This is our last problem. What we have to do with this one is we have to complete the square on it. When you complete the square, what you want to do is you want to group all your x's together. So x squared plus the 6x. I'm going to leave some space for completing the square, and we do the same thing for the y's. 4y squared minus 8y. And then we have to move any constants to the other side, so I subtract that 9, negative 9, to the right side. Okay, in order to complete the square on the x's, I'm going to take half of 6 and square it. I'm going to add 9 and add 9 to the other side. Okay, now this would become x plus 3 squared. Now on the y's, I have to take that 4 out. That would be y squared minus 2y. If I take half of 2 and I square it, I have plus 1. Well, what that would be actually plus 1 times 4 to the right side. So here's what my form is. This is my standard form. It'd be x plus 3 squared plus 4 times y minus 1 squared equals negative 9 plus 9 plus 4, which is 4. And then the last thing that we'd have to do is divide everything by 4. So this is x plus 3 squared over 4 plus y minus 1 squared. This would just be over 1 and equals 1. Okay, so that's my standard form right here. Now let's go ahead and identify all the parts. So the center would be HK negative 3, 1. Major axis. This is where we have to find the a squared value. So this is a squared. So a is equal to 2, which means the axis length 2a would equal 4. So the endpoints, let's go ahead and graph this. We've got our center is at negative 3, 1. And we have to take our major axis as 2 units to the right, 2 units to the left. So those ordered pairs are negative 1, 1, and negative 5, 1. The minor axis. So this is b squared is equal to 1. So b is equal to 1 unit away. So here's a point, and here's a point for the minor axis. So the ordered pairs for that would be negative 3, 0, and negative 3, 2. So here's my ellipse. I had to identify all of the major points, vertices, co-vertices, center. The c value comes from this equation. C squared equals a squared minus b squared, 4 minus 1. So c squared is equal to 3, c equals the root of 3. So the c points are the root of 3 away from each of these, the center, towards the major axis. So the points for that would be, it's negative 3 plus and minus the square root of 3. So I'm adding the square root of 3 and subtracting the square root of 3. I can do it all in the same step. And then up 1. So those are the 2 points, the foci. And then eccentricity would be E equals C over A. So my C value is the root of 3, and my A value is 2. And there you have it. All right, that completes the ellipse for today, and this is your assignment.